An inverse function is the reflection of a graph about the line y equals x. If you don't want to say graph and you'd rather say function, that's also fine. But importantly, it is a reflection about the line y equals x. Now, this line y equals x should be familiar to you because we spoke about it in grade 8 and 9 when we did transformation geometry. So when you did translations and rotations and reflections and all of that fun stuff. And if you do, if you do remember that topic, what you hopefully also remember is the fact that the rule for reflecting about the line y equals x is that you swap your coordinates. And this idea of swapping x and y is going to be very important in this inverse function section. So if you can swap x and y coordinates or x and y values, you're going to be absolutely fine when it comes to inverses. Obviously, we're going to do lots of examples, but that's the crux of it. So just to give you a general reminder of what it is that this line of reflection actually is. So we have our Cartesian plane, obviously. The line y equals x, you should also remember from your hyperbola. It is one of the lines of symmetry that we work with when we talk about hyperbolas. But the line y equals x is essentially that straight line that goes diagonally across through your origin, y equals x. And remember, y equals x means if x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3. If x is -1, y is -1. X is -2, y is -2. Blah, 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 blah. All right, so you've got this dotted line, and essentially what you're doing is you are transforming a point. So let's say, for example, we had the coordinate 4, 1. When you reflect it over the line of reflection, over that line y equals x, according to our rule, we're now going to have the coordinate 1, 4. You have swapped the x and the y and you have reflected. And that's essentially what we're going to have a look at today, this idea of reflecting about this line and how we then go about finding equations of functions that have been reflected about this line. All right, so if we start off slow and we start off by considering our one-to-one functions. Now, grade 12, please remember there's lots of one-to-one functions. I gave you a whole list on Wednesday. One-to-one functions, linear functions, exponential functions, hyperbolas, yeah, those three. Those are your one-to-one functions. Now we're going to have a look at a straight line function because we are going to focus quite a bit on exponentials as of Wednesday. So we're going to just start off nice and slow. And we're going to build ourselves up. So here we've got the function f of x is equal to 2x minus 4. Now this is not anything super stressful. You've all been doing linear functions since grade 8, grade 9. We know how to deal with this. So if we just go and draw this original function, so I'm going to start with the original function. We've got f of x is equal to 2x minus 4. We know that the y-intercept is the c value, so we already know our y-intercept is 0, -4. But we also know if we want to work out the x-intercept, I need to make y equal 0. So 0 is equal to 2x minus 4, which means that 2x is equal to positive 4. And so the x-coordinate of your y-intercept, your x-intercept rather, is 2. So 2, 0. So you've got the coordinates that you need to plot. Okay, so if I go and do that, here's my y-intercept. And here's my x-intercept. I can draw my straight line. Yeah, I'm going to fix it, don't stress. And we have our graph of f. So that graph is f. What we now want to do is we want to sketch the inverse. Now, guys, there are lots of different ways that you can go about doing this. You need to decide what you're most comfortable with. If you are happy and you've got the original function to just swap coordinates that you have, fine. If you actually want to go and substitute into the new equation to find x and y intercepts, fine. Whatever, it's completely up to you. For the sake of going back to what we already know from transformation geometry, I'm going to swap the coordinates. And you'll see now why it would be fine to use the equation of the inverse as well. It gives you exactly the same thing. Okay, that line is going to just upset me greatly. So let's try this again. So this is the line that I'm trying to draw. Is the line y equals x. So third times the charm. And you can see your x coordinates and your y coordinates are the same at each point. Okay, so this is y equals x, and what we want to do is we want to take that straight line and we want to reflect it over. So according to the rule we learned in grade 8 and grade 9 in reflection or transformation geometry, we swap the coordinates. So this coordinate 2, 0 now becomes 0, 2. This coordinate down here of 0, negative 4 now becomes negative 4, 0. And so what you now have is the inverse or the reflection of that line. Again, I'm going to make this better. Go. So this green line that I've got is my inverse. It is a reflection about the line y equals x. We can see that. We can see this mirror image property that it has. Now that's all well and good. It's easier enough for us to draw the inverse from a given graph or from a graph I already have, because like you saw, I just swapped the coordinates. But it's also equally important to be able to find the equation of your inverse. All right, so if you're ever asked, or if you ever need to find the equation of your inverse function, there are two easy steps that you go about. So firstly, our original was f of x is equal to 2x minus 4. Please remember f of x is just a fancy way of saying y. So we've got y is equal to 2x minus 4. That's the equation we're working with. So the first thing that you need to do is you need to swap x and y. And remember that was the basis of this reflection. When we swap x and y, we're reflecting about the line y equals x. So in swapping x and y, I now get x is equal to 2y minus 4. You quite literally just swap the positions of the coordinates, that's of the variables rather. And the second step is for you to go and solve for y. And so you want y equals blah, 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 blah. Whatever that blah, blah, blah is, we will see in a second. So I'm now going to go and solve for y. That means I'm going to add 4 on both sides. So x plus 4 equals 2y. I'm going to divide everything by 2. So x over 2 plus 2 is equal to y. I've got the equation of my inverse. If we just go and double check a few things, because, you know, we like to double check things. This c value is my y-intercept. There it is at positive 2. If you were to go and work out your x-intercept, I'm just going to do this very quickly. X over 2 plus 2 is equal to 0. Bring the 2 over. X over 2 equals negative 2. Times both sides by 2. X is equal to negative 4. There is my x-intercept at negative 4. So it's giving me the exact graph that I drew without an equation. And that's all because we use the fundamentals of swapping x and y coordinates to get our graph. Right, so as we go on this journey here, another thing I want you guys to be mindful of is your notation. Right, so if the inverse is a function, we can use a specific type of notation. And remember, we determine whether or not something is a function by using the vertical line test. So the vertical line test, as long as it cuts your graph once, it is a function. If you go to the light green graph and you do the vertical line, no matter where you move this vertical line, it's only ever cutting this light green graph once. So that means my inverse is a function, and so I can use the notation. The notation is f to the negative 1x, or g to the negative 1x, h to the negative 1x, whatever your label is. And so this inverse function is f to the negative 1x is equal to x over 2 plus 2. If you wrote this as a half x plus 2, it's exactly the same thing. It's up to you. I prefer putting my variable in the numerator, but that's a personal preference. It really doesn't matter. Right, so all we've done is we've used the concept that we had earlier of swapping x and y to find an inverse to go and find the inverse, essentially. Sketch the inverse, find the equation. And like I said, 2 easy steps that you follow when you are going to find the equation of an inverse function is outlined here. Swap your x and y, solve for y. If you can do that, you will be sorted. Exponentials is a little different, but we will get to exponentials in due time. So I'm just going to wait here for you to take a screenshot. Okay, and Kirsten, just to flag you, I do see your message. I will reply in a second. So don't stress, I will reply. All right, guys, but that is essentially an inverse function. We're going to apply this thinking as we go along. So that was a one-to-one function. Let's have a look at an example of a many-to-one function. So if we have a look here, we have our many-to-one function, whatever. We have our many-to-one function, which is a parabola. Now, remember, cubic functions are also many-to-ones. I've chosen the quadratic or the parabola because we haven't done cubics yet. Some of you might have started calculus and might have started looking at cubics, but we haven't done it yet together. And so I'm sticking with something that we know. All right, so we've got f of x equals x squared. This is a nice, easy parabola. No stresses there. Now, guys, this came up in the last class. If you are not sure of where to start your sketching, use the table method on your calculator or just draw a table for yourself. So when I start to plot this graph, I kind of do the table method in my head, which it's because it's quick and easy for me. But that doesn't necessarily mean it's the same for you. If you've got another way to do it, awesome. If you do you, as long as you can sketch the graph. So when I say the table method, what I mean by that is you're going to have x and y, so your inputs and your outputs. And I would say pick 3 x values. I would always pick 0. I would pick a negative, go -2, and I would pick a positive. Because I know a parabola is symmetrical, I've just gone -2 and +2. Really doesn't matter. Pick any x values. My advice is a negative, 0, because where x is equal to 0, this is your y-intercept, and a positive, so that you get the general shape on either side. So if I go and substitute in, this would be -2 squared, which is 4. This would be 0 squared, which is 0. And this would be 2 squared, which is 4. So I've got coordinates I can plot. 0, 0, 2, 4, and -2, 4. I'm just going to plot the ones because otherwise I'm going to struggle to draw this graph. But that's it. That's how I know what I'm sketching. So here's my function f of x. Not a great looking parabola, it's a bit pointy there. So let's try to fix that a little bit. Oh, it's not gotten any better. Okay, I'm going to leave it now because otherwise I'm just going to make it look worse. But there's your function. Okay, we now want to plot the inverse. So just to help everyone here, this is the 0.11. This is the 0.24. -24. -11. So I'm just going to use that logic of swapping my coordinates. Obviously, we've got the coordinates 0, 0. If you swap 0, 0, it stays 0, 0. So that's going to be the same. 1, 1, if you swap that, it's still 1, 1. 1, 1. But now if you go to -1, 1, when you swap it, it becomes 1, -1. If you go to 2, 4, when you swap it, it becomes 4, 2. And when you go to -2, 4, it becomes 4, -2. And so what you end up with is an inverse function that looks something like this green thing over here. Oh, come on, you silly thing. Okay, you get where I'm trying to go with this, hopefully. Wasn't great, but there you go. So this is our inverse. Can someone tell me quickly on the chat, is our inverse a function? So is the inverse a function? Nice, guys. Okay, so no, our inverse is not a function. It fails the vertical line test, so it is not a function. Now, that's not great, because ideally, if we're going to work with an inverse function, we would like the inverse to be a function, but we're going to chat about how we can make it a function in a second. Now, really importantly, because it's not a function, we cannot use this notation, because remember I said the notation is if the inverse is a function. It is not a function. So I cannot use that f to the negative 1x. Instead, I will just use y. Okay, so y equals a relationship. I just can't use the f to the negative 1. All right, so let's get the equation of our inverse. Our original graph was f of x is equal to x squared. So y is equal to x squared. Step number 1, swap x and y. So we've got x is equal to y squared. Solve for y, that would require me to square root both sides. So plus or minus the square root of x equals y. And there's your inverse. We just used y. We can't use the f to the negative 1 because it's not a function. That's inverse. And that is the equation of our inverse. Now, like I say, the ideal will be to have an inverse that is actually a function. And we're going to chat now about how we actually go about doing that. All right, so I'm going to stop here, take your screenshot. Right, so let's have a look. So like I say, the one-to-one functions is easy. If you have a one-to-one function, your inverse is going to be a function. We're not creating a situation where there's a curve and it could potentially go back on itself and create sort of like the parabola here, it's going back on itself and create the situation where the vertical line test fails. When we come to the many-to-one functions, as we have here, this is now where we have this issue of my inverse not being a function. Now, we focus on quadratic functions in this context, this many-to-one. And so what we need to bear in mind is we can make the inverse a function. In order for us to make the inverse a function, we have to do something with the original. And basically what we end up doing is we end up restricting the domain. So you can see it here. If we want to make the inverse a function, we will restrict the domain. Now there's two ways we can restrict the domain. We're going to have a look at both scenarios now. But in order for my inverse to be a function of a parabola, I restrict the domain of my original graph. Now just remember, your domain refers to your x values. So we're going to restrict those arms of your parabola in order to create an inverse that is actually a function. Don't know why that writing is so far up. I'm going to be honest. You would think that I'd be capable of doing this, but apparently not. No, technology is testing me. Okay, I'm not going to fight with it. You get what I mean. Right, so let's have a look at the first scenario where we are dealing with this restriction on the domain. So we've been given exactly the same graph. F of x is equal to x squared, but now we've been given this restriction where x is greater than or equal to 0. So this is my restricted domain. And so what I'm saying is that when I draw this parabola, I only want to draw it for the positive x values. So if we go back up, if we go back and have a look here, essentially what I'm saying to you is that I don't care about any of these negative x values. I don't care about anything to the left of my y-axis. The only thing I care about is this arm over here where all my x coordinates are positive. So that is what the restriction is doing to me. It's sort of cutting my parabola in half at the turning point, and it's only considering one arm of my parabola. So this first restriction is only considering this arm on the right-hand side. Jesus, just okay. So if we go and draw this parabola with the restriction, like I said, we're only looking at it on the right-hand side. So we're only considering this half of my parabola. So this is the graph of f that I'm considering. Yes, there absolutely is this other arm over here, but I don't care about it because I only care about where x is greater than or equal to 0. So there's my function. I now want to find the inverse. Now remember, this is over the line y equals x. If you want to take those coordinates that you plotted and just swap them, absolutely fine. That's what I'm going to do. So the coordinate 0, 0 stays 0, 0, 1, 1 stays 1, 1. But that coordinate 2, 4 now becomes 4, 2. And so what I have, okay, that wasn't great. Let's try it again. What I have is this reflection over the line y equals x. So I've got my inverse function. Hopefully what you now see is that it does pass the vertical line test. I don't have this bottom half, which would mean it's not a function. I only have that top arm, so it passes the vertical line test, and so now my inverse is a function. Now remember, we worked out earlier that the inverse equation was y is equal to plus minus square root x. So now we can actually go and decide what this inverse should be. And because it is a function, I can use my notation. So this inverse function, actually, it's a lot of arrows. Let's do this. This inverse function, look at your y coordinates. This graph only exists where y is positive. It's all these positive y values above x. So that means I'm looking at positive square root x. If I was looking at negative square root x, all my y values would be negative because that's a coefficient to the square root. I'm looking for where all of my x values, all of my y values are positive. And so this is the equation of my inverse function. I think my arrow's going to go the other way. And so this is f to the negative 1. I've created an inverse that is a function through restricting my domain. If we now go and look at the domain and range of each function, now this is not going to be super interesting at this point. When we do the next scenario, it is going to be quite cool to see what happens. But the range of my original, it's from the x-axis up. So it's all my y values greater than or equal to 0. And the domain of my original, remember, this was the restriction. That's according to what restriction I was given. So x greater than or equal to 0. Of my inverse function, the range is again all of these y values greater than 0 because it's above the x-axis. And your domain is all of the x values greater than 0. So x greater than or equal to 0. So there's nothing too special there. You know, it is what it is, but you're going to see something really cool in the next scenario. So scenario 1, when we want to restrict our domain, is to make it, or to make the original function only consider x values greater than or equal to 0 and only consider one arm of my parabola. When I then find the inverse of that one arm, I am creating an inverse that is a function. And so I can now work with the inverse notation and work with all of the characteristics of a function. So again, I'm going to wait here, take a screenshot, and then we'll have a look at scenario 2. And again, Kirsten, I haven't forgotten. I am going to reply to you. I'm just waiting until I give you a question. Okay, so we're screenshotting. And then we're going to have a look at the second way in which we can restrict our domain. Okay. So again, I'm giving you exactly the same graph. I'm not, overcomplicating the situation at hand. What I am now doing is I'm changing my restriction. So same graph, but now where f of x, now where x is less than or equal to 0. So here's my restriction. If I go back up to that original graph, I'll come back down in a second. I only care about the x values less than 0. So basically, I care about nothing on the side of my Cartesian plane. So this whole right-hand side I don't care about. I actually only care about this arm here on the left that I've highlighted in yellow. That's the only one I care about because that is where x is less than or equal to 0. So when I now plot that original f of x, that's what I need to bear in mind. Right, so when I go and plot that, Come on. I'm only plotting on the left-hand side here. So I only care about this arm of my parabola. Again, this is negative 2, 4. This is negative 1, 1. I'm not looking at the inverse. So this line y equals x. Now, grade 12, you do not have to draw this line y equals x unless they ask you to. The only reason I like to have it here, and if you want to draw it in pencil, that's fine. The reason I like to have it here is because it helps me see what my reflection should look like. That's the only reason I draw it in. You don't have to draw it in unless you're asked to. Okay, so I'm not going to draw my reflection. I'm just going to swap the coordinates. If you want to find the equation first and then substitute in through a table method like I showed you, that's fine. But I'm just going to swap the coordinates. It was negative 1, 1, so now it's 1, negative 1. It was negative 2, 4, so now it's 4, negative 2. And so I get my inverse equation here. It's not the best looking inverse, but it's the inverse. You can see it's the mirror image. We're sorted. When it comes to the equation, remember we said it was y is equal to plus minus the square root of x. If you consider where this graph is, it's where all of your y values are negative. So that means that my inverse equation here is negative square root x, because the f of x or the y must be negative because it's sitting below my x-axis. And so this is my inverse function. Now we're going to see something quite cool here. When I now go do the domain and range, the range of my original function is everything above the x-axis, so y greater than equal to 0. And the domain of my original, remember, is your restriction, so x less than equal to 0. When I get to the inverse graph, the range is now all the y values below the x-axis, so y less than equal to 0. And my range is from the y-axis to positive infinity, so x greater than equal to 0. And what I hope that you see is that the range of your original becomes the domain of your inverse. Obviously with the x and y swapped, because remember it's a swap. And then the next thing that you're hopefully seeing is that the domain of the original becomes the range of the inverse, just with the x and the y swapped. And that's what's so cool about inverses. If you know the domain and range of the original, you automatically know the domain and range of the inverse. If you know the x-intercept of the original, you automatically know the y-intercept of the inverse. And so you can keep looking at these relationships. We're going to see this more when we do exponentials on Wednesday. But what's really, really important here, guys, is that you see the swap between your domain and your range, your coordinates, whatever it is that we're concerned about. There is a swap of variables. All right, so let's take a screenshot. And remember, guys, if you've got questions, please ask. I know this is a lot of my voice, but please do ask if you've got questions. And what you're going to now see is a try it yourself scenario. Alrighty. Okay, so guys, you know the drill. Give these a try. Pick which one you're more comfortable with. It's completely up to you. The first one is 3x squared, where x is greater than equal to 0. I want to sketch an equation for both of them. The second one is f of x equals 2x squared, but where now x is less than equal to 0. Okay, guys, I'm going to give you another 2 or 3 minutes. Okay, I'm going to give you another minute or two, and then we're going to have a look. And do you see some answers coming in? Bongi, nice. Okay, let's have a look. But if you're not done, don't stress. You can take screenshots as we go along. Please remember your function notation, and I'm saying that because I know I forgot it when I did these answers, so I will put it in as we go along. So if we look at the first one, the 3x to the power of 2, we're finding the equation of the function. And so just bear in mind, because like I said, obviously I've just been a bit silly. Bear in mind you can use the function notation. So this would be f to the negative 1 of x is equal to square root x over 3. Now I can't tell you why I then chose to draw the function in pink rather than purple, but there we are. I made some weird choices in life. So this pink function is the inverse function. You can see that because I put the label there. So it's not the end of the world. I just made some weird choices in life. This function over here is in your original function, so that would make more sense to be in pink. hence why I'm fixing all of my silly mistakes now. Right. So those are your two functions. Use your function notation because it is a function, and that's it. You've sketched it, you found the equation, that's that. Right, when it comes to the second one, we just need to be mindful of the fact that we're talking about a restriction where x is less than or equal to 0. Again, I've swapped the colors. It is what it is. We're just going to pretend I made better choices in life. Again, use the function notation. So f to the negative 1 of x is equal to minus root x over 2. I saw, and Bongi, I think it was you wrote down negative x over 2 to the power half, as I understood it. That's absolutely fine, because remember, guys, the power of a half is a square root. I'm going to be honest, I've never seen it answered like that, but there's nothing wrong with it. It's technically the same thing. So there's nothing wrong with using the power of a half. Like I said, I've never done it like that, nor have I ever seen anyone, but it's not wrong. So it's absolutely fine. So this was your function equation of negative x over 2 to the power half. Absolutely fine. It's very interesting to see how we all do things differently, but actually it's all correct. Right, again, just look at the labeling. The light green graph is the inverse, dark green graph, the original. Why I chose that, I don't know, but here we are. That is what it is. We've got our graphs. So guys, really important when it comes to parabolas or quadratics. If we want the inverse to be a function, we have to restrict the domain. If we don't restrict the domain, as we saw in that original example, we don't have a function for our inverse. Alrighty, but let's have a look at example 3 here. If anyone needs to take a little stretch, do that, because I do need a little stretch. All right, now, if you want to sort of know how this question will be asked moving forward, this next example is an example of that. So this is sort of the type of example you can expect in an assessment. Now, guys, when it comes to inverses in an assessment, and as you go through past papers, you're going to see this. It really isn't like super complex questions. They will ask you for the equation of the inverse. They might ask you to sketch the inverse and even the original, but you know how to sketch graphs. We've also been doing it the whole lesson. They can ask you to give you the domain and range. So like we did in those previous examples where I had the little table at the bottom and we said what the range and what the domain was. They can ask you that because they expect you to know that they swap. We can ask you for the x-intercept or the y-intercept because, again, you know that they swap. When we start talking about exponentials, it'll become particularly important when it comes to asymptotes, because if you have a horizontal asymptote, your inverse now has vertical asymptote. But that's really all they're going to ask you. They might throw in an inequality question, so like where is f to the negative 1 of x less than 0, or whatever the case is. But we've been dealing with inequalities through our algebraic functions in any case. They might ask you a transformation type question, like what's the equation if it shifts 2 units right or 3 units down, or it reflects over this line. But really, it's not super complicated when it comes to the inverses. Now, this is also why I said to you guys, practice your grade 11 functions, because the inverse function, so functions is about, it's about 35, 40 marks in paper 1. Of that, the max I've ever seen the grade 12 functions in terms of marks, I think has been 12 or 13 marks. So a huge chunk, like 15, 20 marks is grade 11 functions. And so that's why I keep saying to you, grade 11 functions is so important to revise. The grade 12 stuff is easy, you can get that. And so those are the marks you can bank in functions. But grade 11 functions, so important to revise. Right, but let's have a look at this question here. So we have been told that below are the graphs of f and g, and that's all we've been told. We now need to actually go to the graphs to see what's going on. This is not usually how we would present questions to you. We would give you information in the question, but it is also important to look at your graph and see what's going on. So our first graph is g. It is one arm of a hyperbola. Now, guys, I know it's a hyperbola because, let's do this. I know that this graph is a hyperbola because x is in the denominator. Remember, whenever you've got x in your denominator, you are working with a hyperbola. So that 1 over x, that x in the denominator tells me it's a hyperbola. I don't need to think, I don't need to question it, it's a hyperbola. It's one arm of my hyperbola. So that's my graph of G. I've also been given a graph of f, which is this blue one over here, and we've been told that f of x is equal to the square root of x. Now, we've just done a whole bunch of examples where we dealt with square roots. So what we need to remember is that this is a square root function. And so its inverse is a parabola. Because remember, inverses go both ways. I could give you a square root, and to then get its inverse, we would have a parabola. I could give you a parabola, and then to find the inverse, it would be a square root. So inverses go both ways. Just because I've given you a square root as the original doesn't mean you can't then go find the inverse. The inverse just happens to be a parabola. So just by looking at the information you've been given, we've been able to get quite a lot. Now, the reason I've made the point of the fact that a square root function inverse is a parabola is because you can see that you're going to be asked it. I can guarantee you if they give you a log function, an exponential function, a root function, or parabola, they're going to ask you what the inverse equation is. So it's always good to have in your mind, okay, well, if it is a square root function, I know the inverse is a parabola. If it is an exponential function, the inverse is a log. Just that when you actually get your answer, you can look at it and you can be like, cool, that's what I expected to get. You're double checking yourself as you go along. Right, but let's have a look at these questions here. So question A says, doesn't say determine, it says determine the coordinates of A. So now we go to our graph. Here's A. Who can tell me what's special about A? What is A? You're welcome to unmute yourself, remember, if you want, so don't mind. I do see someone sent a message, I'm just panicking. Atia, lovely, well done. It's a point of intersection. Can anyone tell me how we work out the coordinates of a point of intersection? Here's one, nice. See your message here as well, very well done. So guys, how do we work out the coordinates? So here's one, nice. We equate our formulas. Atia, Kirsten, lovely, guys, well done. We equate our formulas or our equations. So what we want to do is we want to take g of x and we want to make it equal to f of x. G of x was 1 over x. F of x was square root x. And now we solve for x. Now, in a situation like this, get rid of that square root. It's gross. We don't want it. They must go away. To get rid of a square root, we square both sides. So 1 over x squared is equal to x. Remember your distributive law of exponents. This will give you 1 over x squared. 1 squared is 1, so I don't have to write 1 squared. I'm just going to write 1 is equal to x. I'm not a huge fan of that x squared in the denominator, so I'm going to times both sides by x squared, leaving me with 1 is equal to x cubed, because x times x squared, x cubed. To solve for x, I cube root both sides, and so x is equal to 1. So now I know that this x coordinate here at A is 1. To find the y coordinate, I sub it back into either equation. I don't care which one. So if you sub it back into g of x, you would have 1 over 1, which is 1. If you subbed it back into f of x, you would have the square root of 1, which is 1. You get exactly the same answer. And so A has a coordinate 1, 1. Now, grade 12s, I've said this before. If I ask you for the coordinate, you need to give me the x and the y. I'm pedantic, and because it says coordinates, I would write it in coordinate form. If you didn't, and you said x equals 1, y equals 1, we will give you the marks, okay? Other markers and the people who mark your papers are not as pedantic as me, and I would never mark my kids down for it. But just remember, if it's asking for coordinates, you have to give x and y. If the question had just said determine the x coordinate of A, you stop at x equals 1. That's all I wanted. You don't need the y. But read your question very carefully so that you're not missing out information, because it would be so silly to lose a mark because you forgot to sub back to find y. Right, but now we know where a is. That's awesome. Question B says, determine the equation of the inverse function of f in the form f to the negative 1 of x equals blah, blah, blah. And I said to you, when we went through the graphs and we looked at it, if I give you an exponential, a log, a parabola, or a root function, 99% of the time, somewhere you're going to be asked for the inverse. And this is exactly what's happened. So we now need to find the inverse of this function. So the original function was f of x is equal to the square root of x. We want the inverse. Remember, f of x is a fancy way of saying y. And so the rule is swap x and y and solve for y. So I want you guys to do that for me. Work out what the inverse function's equation is. Swap x and y and then solve for y for me. I'll give you like a minute. Let's see what we get. Good 12s. Give everyone another minute and then I'll do the answer. All right, amazing, guys. So we swap, so this becomes x equals square root y. Don't really want that square root there, so I'm going to square both sides. X squared is equal to y. Now, remember, x squared is a parabola. A parabola is a function. So we are definitely able to use this notation, and we were also told to use that notation. So our final answer has to be f to the negative 1x is equal to x squared. We were told to put it in a specific format. We have to do that. If it tells us to write it in a format specifically according to whatever, we have to do that. All right, so question C says, sketch the reflection of f about the line y equals x. Now, because we have had the discussion and because we know what this means, we know that the line y equals x means sketch the inverse. Because remember, your inverse is a reflection about the line y equals x. Now, you've just found the inverse equation. So if you wanted to go substitute in values, that's fine. But bear in mind, you've only got one arm. Oh, God, this money. You've only got one arm. Okay? You've only got this arm of your root function. You don't have the whole inverse parabola, so you're not going to draw the whole parabola. If you look at the arm you've been given, this is scenario 1 that we spoke about. That's the arm that you were given. So the inverse should be the right-hand side of your parabola when you now go draw it. Now, guys, it's a sketch. It doesn't have to be perfect. It has to pass through 0, 0, because if it starts at the origin, if you swap 0, 0, it's still 0, 0. And it has to pass through A, because if you swap 1, 1, you still get 1, 1. But just make sure that when you now draw it, it curves up like a parabola would. And you've got your graph of f to the negative 1 of your inverse. You don't have to plot a whole bunch of points. It doesn't have to be perfect. Obviously, if you want to, by all means do that. But then just remember that because of the arm that you're working with, you are working with the restriction on the domain whereby x is greater than or equal to 0, and you should only be subbing in positive x values. But that's it. It doesn't have to be perfect. This inverse that I've drawn is absolutely fine for I mean, it would probably be 2 marks. I would get my 2 marks. I've done what I needed to do. I've sketched it. It is proportional to what's going on. I'm happy. Okay, so I've sketched the inverse. This was the inverse that I just sketched, bearing in mind that it's only for where x is greater than or equal to 0. Right, as I'm saying this, for our inverse function, we should actually have our restriction here as well of x greater than or equal to 0, because it's not the whole parabola, like I said. It is only where x is greater than or equal to 0. And so when you are finding an inverse equation and you have to consider the restriction, please do that. Right, when we look at the last question here, question P, I've got 2 minutes, I'll get it done in 1. We have been asked to write down the equation of P, the reflection of G about the y-axis. Now, this should take you back to grade 8 and grade 9 transformation geometry as well. When we reflect about the y-axis, x value becomes negative or changes sign. Doesn't really matter how you choose to view it, but basically the sign changes. So if it was negative, it's now positive. If it was positive, it's now negative. So g of x was our hyperbola, 1 over x, which means p of x is now where this x coordinate is negative. So 1 over negative x, which means p of x is negative 1 over x. That's it. Okay, so when it comes to doing reflections, you have all of this knowledge. Please don't ever doubt yourself in the knowledge you have. It's there. Yes, it might have been taught to you in grade 8 and grade 9, and I get that that's like a whole nother lifetime. I understand that. But it's all there. You are applying the rules that you already know. You have got everything in those beautiful brains of yours. It's there. You just need to apply it. All right, so that was example 3. I'm just going to leave it there in case anyone wants to take screenshots.